What's up, everybody? Today we're going to be talking about a pretty interesting technique in the domain of large language models and natural language processing in general. We're going to be talking about retrieval augmented generation, or RAG. It's a super powerful method that can really, enhance the power of your large language models and really increase in performance if you're trying to use these large language models for production. So let's go ahead and jump right into it. So before I talk about RAG, let's just revisit the structure of how the large language models work. I'm sure we're all familiar with things like ChatGPT and things like this, but we'll build on this diagram later. All right, so we might have some user input, and let's just talk about this in generality. So it might be something like, how do I do X? Or it could even be something like, can you answer this question? Maybe looking for something like a fact, or maybe even an insight based on facts. So these are the types of things you can ask a large language model. So these are types of user inputs that can be input into these. And then the large language model will input this kind of thing, process it, and output a response. So let's draw that in a diagram. So let's put the large language model, LLM for short. Let's just write it out, large language model. And then we'll put LLM. Right. So the user input gets input into the large language model. Let's move this over here. And the large language model does some processing and gives the output. So let's talk about that one. So put that there. Response. All right, cool. So that's basically a nice summary of how large language models work as a black box. So basically what I mean by that is we're kind of taking the large language model for granted. A lot of work goes into creating these things and making them work. But if we take that as a quote unquote black box, then this is how they work in this basically two-step process. So let's talk about a couple of the problems that arise in practice when using this kind of setup. So the first thing is that the large language model will actually tend to make things up, especially if it doesn't really know what the answer is. This is called quote unquote hallucination. So that's one thing that comes up, is that the reliability of the response is in question when you use this process. A second thing that kind of comes up is, when we're answering a question as a human, sometimes we don't either remember or know the answer off the top of our head, but we know where to look to, find the answer. For instance, maybe a Google search, or maybe we'll check a book or ask someone else, something like this. So allowing the large language model that ability to ask relevant sources can actually really improve the effectiveness of and put less into question the reliability of the response, going back to the first point about the issues with this current process. So that's actually what retrieval augmented generation, or RAG, attempts to do, is give the large language model access to additional information that can be used to generate the final response at the bottom of the screen. So let's go ahead and modify our diagram to see how that's going to look. So the first thing I'm going to do is actually going to get rid of this and this, so we can focus completely on the diagram. All right, so the user input actually gets input over here into something I'll call your data. And we'll explain a bit more what this could be, but let's just draw an arrow. So this is where the user input's going to make its first stop. So what do I mean by your data? So there's a bunch of different things that could come from this, but it might be, say, your documents, public documents, or text, and let's put text here as well. Really, everything should be text at the end of the day. It could be maybe a Google search, and so on and so forth. So you can see this your data blob could actually get quite big, right? Google search, your documents, public documents, that could be a huge chunk of text. And figuring out which one is relevant to the user could actually be a pretty challenging problem. So in light of that, there's a lot of techniques out there for that. I guess a popular one is a so-called vector database, which maybe we'll talk about in another video, but definitely not here. But that's just a method for figuring out of this, massive pool of text, which part of it is actually relevant for the user input. So your user input is kind of compared with all this, this perhaps massive chunk of text. And the upshot is eventually you're going to kind of sift through this data and figure out which ones are relevant to the user input. So I've added this box called context, and this context is a very small set of text coming from the previous box of your data. And these are supposed to be relevant to the user input. So now not only do we have the user input, but we also have a bunch of context from our particular data that might be relevant to the user input. So now not only do we have the user input, but we have a bunch of context coming from whatever data you think might be relevant for the user input. So for example, if you're trying to say onboard someone at your company, perhaps something that might fall into your data is some internal documents that you've created that are supposed to maybe describe the job. So for instance, if you're trying to onboard a new employee at your company, some of the data might be, say, some internal documents that were created to describe what you're supposed to do at the job, or maybe some external documents that might describe some rules and regulations related to the job. So these are type of things that might fall under your data. And then the context might be like a actual paragraph from this document that's related to the exact input of the user. Okay, so now that we've done that, we can actually just create one more arrow, and that's going to be the context actually gets input into the large language model along with the user input, and then the large language model processes everything together to get a response. Oh, I notice I have a typo over here. Let's fix that. So instead of publics, it's actually just going to be public. All right, that's kind of the end of the creation of the diagram. So let's talk about it a bit more. So again, the whole point is that we're trying to answer some sort of question. And there's a lot of situations where just having a little bit of additional information can really improve the performance of the model. So that's the whole point of incorporating your own data. Now the process of incorporating your own data is pretty complex, and that arrow that goes to the right to your data and then finally to the context below, that's a pretty complicated sequence of events. And we're not going to talk about it here, but just know that there are some pretty decent methods for extracting relevant context from massive chunks of data. So knowing that, this is actually pretty nice because we can literally input, once we have, the user input, we can even put into the prompt, which is, what happens. Hey, this is like some pretty relevant context. Make sure to keep that in mind when you are answering this question. And the large language model will typically oblige. All right, so I think I'll end it here. I hope you understand a bit better how RAG works and how it can be used to improve large language models. So thanks for watching. I hope you liked it, and I'll see you in the next one.